Creating a surface in Trimble Business Center is very simple. Under the Surfaces tab, select Create Surface. I will call this Stockpile 1 for the surface name. I have the ability to classify the surface material. This is useful when comparing surfaces to one another and creating earthworks reports based on the difference in volumes. There are several types of classifications such as original ground, design, as-built, and stockpile. I'm going to select the stockpile classification, as this will allow me to compare future volume surveys of these stockpiles in TBC. I can also select the color for the surface as well as the date surveyed. In this case, this survey was performed on August 16th and at around 2 p.m. And then I'll select the members to form the surface, which will be my point cloud. And then I can select Apply and OK. Selecting Apply creates the surface but does not close the command. Selecting OK creates the surface and closes the command. Point, line, alignments, and point clouds can be used to generate surfaces. In the Project Explorer, I'll turn off the point cloud, and now you can see the newly created surface. In the Project Explorer, there is now an object called Surface. Like other objects, the surfaces are located in the View Filter Manager as well, and can be turned on and off. If you view the properties, there are many options for showing and altering the surface creation. The maximum edge length allows users to specify the maximum triangle edge length for each surface triangle. You can also change the tolerance for removing flat triangles in your surface. Depending on the type of terrain you are creating surfaces from, this tolerance may be very useful. Display flags are shown when TBC notices inadequacies in the surface, such as vertices on top of vertices. You can select the rebuild method for the surface, whether that's auto or selected by the user. The transparency option is for changing the visibility of the surface. The shading option will create surface shading based on a slope percentage. Next, there is a pane for plan viewing options and also one for 3D view options. These define how the surface area is rendered in each individual view. Wireframe option is useful for editing the individual surface triangles and finding areas of the surface with issues. You can also turn on vertices, break lines, and drape lines that are a part of the surface. Turning on the option to show slope arrows helps users to better visualize where and what direction the slopes are. This is great for determining drainage patterns and other flow-type terrain. The shading option is another neat visualization tool. My preference is to shade by elevation. The bright color scheme allows me to note areas of high and low elevation. When viewing the Show in 3D View options, the only option that is added here that isn't in the Plan View options is the Show Back Faces option. This allows you to view faces that are underneath the surface that can be seen in the 3D view. The final two panes are in regards to densification and summary results. These will be covered in another tutorial video. Now that we have a surface, we can clean up any unneeded areas such as long triangle edges, add surface boundaries, and add break lines. There are areas of the surface I do not want to include in my earthworks analysis. The first tool is the Trim Surface Edge tool. Users are able to remove areas of the surface edge that shouldn't be a part of the surface. In this case, there's a long surface edge that I do not want to be triangulated in the surface creation. What I can do is use the line select from this command and select the surface edge that I want to remove. Press OK. This removes the unwanted surface edges, and now I have a cleaner surface. Another method is to use the swap surface triangles. Any of the surface triangles that are incorrectly triangulated can be reversed in the opposite direction. The next tool that is useful for editing surfaces is the surface edge break line. This is useful for preventing edits to the outside triangles of your surface, as well as to edit the surface edges. When using this command, it will automatically create a line string on the boundary of the surface. This line string can be edited and moved to alter the surface boundary. The surface will automatically recompute when you move this line string. If you add surface members outside this break line, the breaks will not automatically update to reflect this, but it can be changed to include this area. Another way to create a boundary is to use the add or remove surface boundary. A boundary can be created in the form of a closed line or polygon, and it needs to be supplied as well as a surface to be bounded. For this command, a boundary in the form of a closed line or polygon, as well as a surface to be bounded, is needed. There are two ways to create boundaries. The first is to use the line string command to draw a line around the outer edge of the surface with the auto close option selected. As I draw the line string, if the correct snaps are applied, it will snap to the surface. This option is great for stockpile measurements, as you can snap the line string to the existing ground surface or provide a design elevation to the line string point. Once the boundary has been created, select it and press Add. This removes anything outside of the boundary from the surface. The second is to have measurements for the closed figure. This is useful in cases where the positions of the extents of the volumetric work is known, such as in foundation digs or in mines. In this case, we have GNSS measurements that were taken around each pile and feature coded. To process this feature coding, select the feature code option from the Survey tab. Select the JXL file. In this case, I want the GNSS file that I want to process, and then I'll press Process Sources. This automatically creates closed line strings around each pile. Now I'll use my boundary and the Add or Remove Surface Boundary command. I can select this feature-coded line string to use. And now I'll press Apply. You can see that it's trimmed the surface relative to this boundary. Panning around the 3D view, you can see the surface is now limited to this boundary. Now that our surface is cleaned up, we are ready to create deliverables.